Hello and welcome back. Today is day 12 of our graphing quadratics unit. We will be solving quadratic word problems involving maximums and minimums. Just a reminder, a handout of this lesson is provided in the description below. Thank you and enjoy. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Let's go over this do now. A store sells about 400 iPhones each month at $800 a piece. If the store decreases the price by $10, then it sells about 20 more phones. Calculate the amount of sales for each of the following. Okay, so we know a couple things. We know that they sell about 400 iPhones each month and they're $800 a piece. Okay, but also we see over here that is if they change the price by $10, then what happens? Then they increase the number of phones they sell, so 20 phones. Okay, so let's see if we can notice anything. So let's go ahead and let's start writing this out. So the current price, or the price, the sales that they'll make, they should have 400, and then just multiply that by 800 and you'll get some number. I'm not going to do it yet. I'm not going to calculate it out because I want you to see something in a second. But now let's use the same logic that they told us in this problem. They said is if we decrease the price by $10. So I'm going to put a little dollar sign here. So the 800 is now going to be down to 790. So they're going to decrease the price to 790. Well, that told us that the sales for the number of phones that they sell should go up by 20 phones. So now they should sell 420 phones. All right, and then that's going to give you some number. And then you'll just do it again. So the next time, what happens the next time? So the next time, they're going to decrease the number of phones the price they sell. So now it's going to be $780 a phone, but then they're going to sell 20 more phones. So then that's going to be 440. All right, and then we'll continue on. We can continue this forever. So this is going to be the next one decreased by $10, so it should be $770 a phone now, but then they're going to sell 20 more phones, which is 460. All right, so now let's take a look at this answer. But to take a look at this answer, we're going to use another program. We're going to use a Google spreadsheet because, again, this is a table and it's a lot of calculations. To me, that means I should be using like some technology to help me see this answer. So let's go ahead and do that. As you can see, we have a Google Sheet open. So I would open up a Google Sheet so you can follow along and see if you can recreate this table also. And in the next problem, before solving it by hand with the formula, use a Google Sheet and see if you can figure out what the answer is. So interval. I'll tell you what this is in a little bit, but let's enter a value in here. So we're going to go 0. And then we're just going to increase by 1 every time. So 0, then 1, then 2, then 3. So if you've never used Google Sheets before, if you want to create like a formula to have it automatically done for you, then you would enter like this, equal sign, make sure you enter the equal sign, and then we're going to take the contents of A2. So you see how the green cell is in column A and it's in row 2, so we call that A2. And then I'm going to do something to that block. I'm going to add 1. And now when I press enter, boom. So all it did was, if you look, this box right here takes whatever's in the box A2, and then it's going to add in the cell A2, and then it's going to add 1. All right. What do we say? We know that for interval 0 that we sold 400 phones, and we know that the price per phone was $800. Okay. Now the same thing, like I didn't calculate it in the warm-up, the answers, because I knew I could do it here really quick, and it could do it over and over and over again. So again, in this box for total sales, I want it to do the calculation for us. I want it to multiply 400 times 800. So what we're going to do is we're going to write another formula. So we'll hit the equal sign first, Then we'll hit what cells are they in? 400s in the cell B2. So I'll type in B2, and then I'm gonna multiply. I'm gonna multiply by C2. So you see that? So the green cell is the 400 and the C2 is that red orange cell there. Okay? And then I'll press enter and it'll calculate it for me. All right, now I'm going to want to keep that rule going over and over again. So instead of typing it in just like last time, so that last one was equal sign A2 plus 1. Now instead of just keep typing over and over again, usually you can hit on that, you can click on the bottom right hand corner of this cell and drag and drop, and it will just copy the rule over. But since I'm on a tablet, it's getting a little harder. So I'm going to need to copy the rule. So I'm copying the rule, and then I'm going to drag this down, and I'm going to keep dragging all the way down. Let's go right about there. So I'm going to drag, and then I'm going to paste the rule. So this is going to allow me to paste, and then there we go. So what we should see is that the rule just got copied down. So now we have the same rule over and over again. Just add one to the box above it, add one to the box above it. And now I have a whole bunch of boxes in here. Now, what happens when we decrease the price by $10? And we increase the phones by 20. So again, instead of just manually typing in here, let's use a formula. Let's write a little formula in here so that way it goes a little faster. So let's take whatever's in C2. So I'm going to take the C2 box, and then I'm going to subtract. I'm going to subtract $10, and then I'll press enter. And as you can see that we decreased the price per phone by $10. But now I want to copy that rule over and over again. So let's copy that rule. Copy, and I want to drag and drop that rule all the way down so that way I can do this I want to do that calculation over and over again. So we're going to drag that all the way down. I think we went all the way to 60. So let's keep going. Drag, drag, drag. It's much faster on a PC. Oh, 72 is where I stopped. Okay. And now I'm going to paste that rule in there. Paste. Now this should decrease by $10 every time. Didn't work. Fail. So this one, let's change that rule. Take C2, and we are going to subtract $10. Okay, we're going to copy that rule, copy, and we're going to drag and drop that down all the way. And as we do this, everything should just decrease by $10 each time. So I think we went all the way to 70, 72 is what we went to. Now let's paste the rule in there. Perfect. So as you can see, it keeps decreasing by 10, decreasing by 10. So if we go all the way back up, so now that's why I named these intervals. So after one interval, that means after you decrease the price by $10, you're at 790. If you do another interval, now you're at 780. You do another interval, now you're at 770. All right, now what happened to the price of the number of phones sold? Well, the number of phones, those increased. So those are going to be, let's do equals, and we need whatever's in B2, whatever's in that box, and then we are going to add $20 to this one every time. So add $20, okay? Press enter, and there we go. We added the $20. But I want to copy that rule now. And I'm going to drag and drop it all the way down. Okay, let's see if I can drag this rule down over and over again. Let's see if it works. Okay, right there. Paste. Perfect. All right, so as you can see, all I've done was create a table here. The price per phone you see decreases by $10 each time. The number of phones sold increases by 20 each time. And now we can quickly find the total sales. It got deleted somehow, so I'm gonna have to type that back in there. So this will be equal to B2 times C2. Perfect. And enter. Okay, now let's copy that rule and let's see this price over and over again. Let's see what happens here. I want to check out the price as we do this. Paste. Bam. Okay, perfect. So look what happens here. So as we decrease the price of the phone, we should notice that the total sales start increasing. So if you just increase it by $10, you'll make about 11,000 more. And keep going, and you notice the price just keeps going higher and higher and higher and higher, and it just keeps, and then something's happening. Now we get to a point where now the price is getting lower and lower and lower. So again, you can't, what it tells us is that we can't just keep lowering the price till zero, because then you're not going to make any money. But now this should lead you to a question. Where is the answer? What is the best price that we should sell the phone for to make the most amount of money? A lot of our problems break down to this. What should we charge for this phone in order to get the most money out of this phone? So if we look at this table, let's find the spot. And what do we see here? The most amount of money will be right here. So if we decrease our 30 intervals, so it'll be in this little spot right here. The most amount of money that we can sell for this iPhone, we can get back up to $500,000. All right. And so your job today is going to be, okay, how do we do this by hand? So now it's nice to use the technology. That's awesome. But I want you to know how to do this. How do we use our algebra to actually do this? How do we figure out the price using our algebra? And that's what we'll be learning today. Try to use some algebra and try to solve this problem. So the store sells 400 iPhones at $80 a piece. So I'm going to write a little function here. So I'm going to say your total sales, and just for one example is all we do is take the 400 and then we multiply it by the 800. Perfect. But now there's some things that we need to keep in account here. We need to decrease the price by $10 each time. So now how do we do that? That's just a function. How can we do that? So what we should know is that, so your total sales can be written as a function, and I'm going to write this a little bit larger. And remember, one of these is price, so this $800 is your price. How do we write a function that says like decrease by $10 each time? Well, that's pretty simple to me. That's just a linear function. So take the 800 and we are going to decrease, so that means I'm going to subtract by 10x. So now see if that makes sense. And now in this problem, I'm going to have to say that x is going to mean our interval. So for my interval for this problem is x is the interval. And I'm going to call y my total sales. Okay. So again, I'm going to switch my total sales over here to be a y in a second. So this will just be y. But does this make sense? So every time our interval increases, so what happens after the first interval? What happens after the first time you decrease? Well, I want to decrease by $10. So if x is 1, then I'm going to go 10 times 1, which is 10. What if you increase it to twice? Now it would be, well, 10 times 2, which would be 20. And so on and so on and so on. So like the 10th time would be, well, $10 times the 10 would be 100, and that would work out perfectly. Now the same thing kind of goes for the phones. So the phones, we know we sell 400 phones, but then this time what's happening? We are going to increase by 20 phones each time, or each interval. So I'm going to add, on this problem, I'm going to add 20 phones, so 20x. Now does that make sense? So the first time we did this, that'll be 20 times 1, which is 20. The next time we do this, if we decrease again, it would be 20 times 2, and there you go. And every single time that would produce that value that you need for your phones. So now this leaves me with an equation. So I have an equation, y is equal to 400 plus 20x times 800 subtract 10x. And there's my function. And this graph would tell me, okay, this would be able to tell me the number of sales per interval that I have. So first thing I should notice is that this is going to make, if I multiply this out, this is a quadratic, and it's going to be concave down. So I should know that this quadratic is going to be concave down. It's going to look like this. All right. And we're going to eventually want to find the highest point on the graph, because that'll be your maximum price, because total sales is our y value. So when we graph this out in a second, let's start making the graph right now. So what does the graph look like? So if that's my function, what will the graph look like? So let me just sketch a graph here. So here's a graph. That looks beautiful. X is going to be, I called it my interval. So each interval that we have, y is going to be my price, or the sales amount, so the amount of money that we have here. So now, how would you graph this? Well, if I'm looking at that one right there, that equation, that's in factored form. So I know I should just find my roots. So let's find the roots of this. So if I took this problem, y equals 400 plus 20x and 800 minus 10x. Now I'm going to find the roots by just using the zero product property. So let's solve both of these equal to 0. So I'm going to say 400 plus 20x equals 0. And I'll solve that problem. Whoa, why does it say equals 10? So let's solve this problem. So I'm going to use the zero product property for this one. So I'm going to write, so 400 plus the 20x equals 0. That's going to be one problem. Let's solve that real quick. So this will turn into 20x equals negative 400. And then divide both sides by 20. So I'll get negative 20. So I know I have 1 0 over here on this side at negative 20. So there's 1 0. Let's solve the other one. So the other one, let's do this. So we have 800 minus 10x equals to 0. Solve that. So you got negative 10x equals negative 800. And x is equal to positive 80. So now I have another 0 over here at 80. So now you have two of your zeros, because it was in factored form, of your quadratic. So you know your quadratic is going to look something like that. So how do we find the vertex? Your job will be, how do we find this vertex? Because that'll give me the maximum price that we can make on these phones. Well, that should be simple, because let's just find the axis of symmetry. So the axis of symmetry, and remember, how do you find the axis of symmetry in something in standard form? We're just going to add up the roots and find the average of them. So we're going to do that. We're going to say, well, we have negative 20 plus 80 divided by 2, which is 60 divided by 2, which is 30. So that tells me my axis of symmetry is going to be right here at 30. So I should be able to plot a axis of symmetry right there at 30. And then we're going to use that value, 30, to find out what is the maximum price that we can make. So that shouldn't be too bad either. We should be able to figure that one out pretty quick too. So how do we do that? So hopefully you can see your algebra skills are picking up now. Now we're starting to use these functions, find little parts of them, and now we're going to evaluate what is the y value. 2x when x is 30. So we're going to go 800 minus 10. 800 minus 10x. So we're going to substitute the 30 in. So now this will be 400. I'm going to just do it in my head. 2 times 30 is 60. So plus, sorry, that's a 20. So that's 600. My bad, that was a 20 because of back from my equation. And then over here, we get 800 minus 10 times 30, which is 300. And we have a value of 1,000 times 500, which is, your y value is 500,000. Perfect. So that tells me that if we can decrease 30 times, we should be able to sell this phone and make $500,000 for this one. All right. And remember back what happened when we saw that was the max price. So let's take a look here. What does that mean? So that means the price of the phone should be, we should be able to tell right here, the price of the phone for this problem. So I want to sell, the price of the phone should be $500. That's the best price to sell this phone, because that's going to be, 30 times. And then if we do that, we will sell 1,000 phones, which equals total sales of $500,000. Pretty fun little math problem. Pretty cool little math problem. And again, let's check this out on Desmos just to kind of give you another view. This is the sketched out version of the problem, but just to give you another example of what this looks like. And hopefully you're noticing your skills in using technology are also improving also. So hopefully you're picking up some technology skills will help you do the math and actually do harder problems as we keep going. So again, I've already graphed the equation from our problem. I can't see anything because obviously our roots are off the page here. So remember, we have one root at -20. So let's click on the wrench and let's change my root. Let's change that to -30. So that way we know we can see, yep, there's the -20. And then the other root, I believe, was at 60. So let's go to, I'm just going to go to 100 just to be safe because I forgot what the answer was. Oh, it was at 80. So now we can see the roots. Now we don't see the maximum point on this graph, so let's change it. And we said it was 500,000. So that means I need to change my y value to, let's just change it to 1 million. 1 and perfect. 1 million and beautiful. And there's the graph for this problem. So let's take a look. What do we see here? So what is this point? This is when we don't decrease the price. If we just leave the price the way it is and just keep it at $800 a piece, we should sell that much money worth. We should get that much money in sales. But what we found out in this problem was that the best price is to decrease the price 30 times. So that was 10 times each time. So decrease the price by $300. If we decrease the price by $300, we should sell 500,000 worth of phones. All right, so again, it's a much better scenario if you decrease the price, but again, it gives us a look at how we can use our algebra to actually solve these problems. So now you've seen how to use Google Sheets, and you see how to use Desmos, and you can start doing all these problems with a little bit of technology and with algebra. All right, same type of problem. An electronics store sells about 70 televisions, so now we're selling televisions. All right, and the price of these is $320 each. But in this case, it says for each $20 decrease in price. So if we decrease the price by $20, we sell about 5 more televisions. All right, so how much should the company charge? So again, we want to find, again, the maximum price that we can sell for these. So let's write ourselves a little equation. So I'm going to write a little equation. So y is going to be, again, so again, I'm going to use x for my interval again. And I'm going to use y for my total sales. So my equation is going to be, so we know we just multiply, let's just write the first example. So the first example would be, well, I'm going to take 70 televisions and I'm going to multiply by $320. This will give me my sales. But what's happening each time? So again, so this is the money right here. Okay? So they're saying that we're going to decrease the price by $20. So we should know that, I'm going to write this a little bit larger now. That means we're going to take this $320 and I'm going to decrease it by 20x. So every time I'm going to decrease by $20. But every time as we decrease by $20, we need to increase the number of TVs that we sell by 5. So we need to actually go over here now and we need to add in 5x. So every time we decrease by $20, we need to increase by 5 the number of televisions we sell. And again, same type of problem. So we should know this is a quadratic. And if I want to find the maximum point of a graph that's in a factored form, I'm going to find the zeros and then I'm going to cut that in half and find my roots. And then find my vertex. So let's go ahead and do that. Let's find the zeros real quick. Where are your zeros at? So solve both these problems. Let's do the left one first. So 70 plus 5x equals 0. So x equals, that is negative 70. And how many times does 10 times 14, I believe. So I'm going to go with negative 14. There's one of my zeros. Where's my other zero? So this one will be 320. Subtract 20x is equal to 0. So let's find my other zero. So that'll give me negative 20x is equal to negative 320. And x will be 16, it seems like. Perfect. So let's sketch this out. So what does this graph look like? So if I had a graph, there's my graph. I am going to have one of my roots be at negative 14. And you notice I'm not doing like a really neat graph. I'm just sketching it out. And my other one will be at positive 16. So the quadratic will go through these roots and look like this. Something like that. So what are we looking for in this problem? We're looking for the vertex. We're looking for the maximum price that we can sell these for. And again, if it's in factored form and I know my roots, then I'm just going to find my axis of symmetry. So I'll do that real quick. Axis symmetry. So let's take x. Let's add those roots up. So what is 16 plus a negative 14? And then divide by 2. So that'll give me, that's 16. That's 2 divided by 2 is 1. So guess what? My axis symmetry will be right here at 1. So So what does that tell us? Well, that tells us we don't need to change our price too much because our price is not going to be, it's not that bad. So the maximum price that we will be able to do here, so let's figure out what that is. So we know that if we decrease the price one time, then we should get a sales amount. Let's figure that out. So y is equal to 70 plus 5x times 320 minus 20x. But then we're just going to substitute 1. So the best price is just to decrease the price $20 one time. So that means we're going to sell 75, because I'm going to substitute a 1 in there. So we'll get 75 televisions at 300 a piece. So let's check that out. Let's see what we get for that. So y is equal to 75, I believe that is, so I believe that is 22,500. So that will be the best price that we can, that's the most money we can make from this problem. I'm not even going to fit it in this little spot here. 22,500. So if we can decrease the televisions by $20, we will get the maximum price. That's what we're going to have for this one. So very good. So again, let's take a look at Desmos and let's take a look at this guy and see what that looks like. I've already graphed this for us. So there's our equation. Let's take a look here real quick. Let me see if I can zoom out. You can't see my intercepts, so I need to go all the way to, let's go to -20 for my left bound. Perfect. And our other one was 14, I believe. So let's go to +20. Let's see if we can see what, yep, perfect. I can see my graph. I can see the roots. And the maximum value, what do we say, was 22,000? So let's go to about 30,000. So let's change our y value, the max y value to, let's change that to 30,000. And boom, perfect. So let's take a look at this graph. Beautiful graph. I love Desmos. So there's my zeros. There's the roots that we found. And then halfway in between there, let's just type it in so that way it looks beautiful. So x is equal to 1. That's what our, perfect. And look at axis symmetry, cuts right through the vertex. And we found the maximum amount of money that we can make if we change the price. So all we had to do really to get a little bit more money, let's see how much money we actually made more. So it looks like you increase by $100. So if you lower your price by 20 bucks, you'll sell 5 more, but that's only going to be $100. So you're pretty close. That's why I said we didn't have to change the price too much on this one.